All right, good morning. So, yesterday we learned about protocols. I want to talk about some more protocol stuff. Cool. Did you all get to try number 6 on the lab? Thoughts, feelings? Let's take a look at it. I think Ben took a great amount of pride in making this. Let's check the Git log. So if I go into the commits on GitHub, I can see what would be the Git log. Oh yeah, he was so excited to add this yesterday. He was like, I'm so excited. Just gonna paste something in. It came from Apple's tables and persistent protocols. Cool. All right, let's have a look-see at the question itself. Damn it. Question 6. I need you to format correctly, please. All right, so this is annoying. I'm going to pull it down instead. I'm going to clone the repo. Let's check where I'm at. Go into assignments, go into labs, cool, git clone, that, protocols lab is what I'm going to call it. Great. All right, there's nothing git tracked here. Let's see what's in my protocols lab. Let's open the README. Come on, Xcode. Nice. Okay. Awesome. I'm going to take all this code and put it in a playground. Open a new playground, blank playground. We'll call it Lecture82 playground. We'll put it on my desktop in 6.1 for now. I'll move it around later. Oh. Okay. So, let's paste that all in. Protocols lab, question number 6. I'm just gonna comment out a bunch of stuff. Change this up from Markdown. I know. So what was this question about? Can someone sum it up to me before we read it? What's the real life situation that we are simulating here, or that we are analogizing here? Heart rate. Do you want to use verbs or full sentences?
It's trying to simulate the reading that you would get from a heart rate monitor.
Cool.
You would get a reading every 2 seconds.
Simulate the reading you would get from a heart rate monitor, specifically the reading you'll get every 2 seconds. Great. All right, let's read a little bit. The heart rate, blah, 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 class. Below represents a very simplified example of a class dedicated to receiving information from fitness tracking hardware. Cool. With monitoring heart rate. So, if you've ever used a Fitbit or maybe an Apple Watch or like does Garmin do that crap now? They've found a way to track your heart rate by getting some signals. And what this is going to do is probably give you a simplified version of how the UI works. The function start heart rate monitoring example will generate random heart rates and assign them to current HR, probably current heart rate, simulating how an instance of heart rate receiver may pick up on new heart rate readings at specific intervals. Heart rate view controller, which is a different thing, is a view controller that will present the heart rate information to the user. Throughout the exercises below, you'll use the delegate pattern to pass information from an instance of heart rate receiver to the view controller so that any time new information is obtained, it is presented to the user. So we've talked about delegation in the context of protocol, but we also said that it's a broader way of passing behavior. We're going to go in a deep dive in our next lesson on Monday on how delegation works, how we'll use it on UI elements, and how we'll use it in general. For now, I think they give you a hint on how it can work. So let's look at heart rate view controller. Great. Doesn't tell us anything, but they're going to give you some directions on how to do it. So let's look at our receiver. Current heart rate, which is an optional int. There's something called a did set here. Did anyone intuit anything about this did set? Sunny.
It's a computational value, a computed value.
It's similar to a computed value. It has a different name though. What does it do? Can you tell me about that?
Oh, it's not a stored value. So it does a thing, but it doesn't hold any data.
Does a thing, but holds no data. When does it do that thing?
If there is a heart rate.
So it does that thing in a slightly different situation.
Checks.
After, what about checks? Like checks mix or checking what? Checks that something occurred with the variable. What does it check? What's the verb in its name? Cool. When does it do that thing? After the value for this var is set. So this is not a computed property. Instead, it's what we call a property observer. So it's something that's sitting there and waiting for you to set the value of current HR. And this is saying, when you do something with current HR, you should also do something else. It's kind of like a function that gets called when you set the value of this specific variable. When this block of code is called, the time when this block of code is called is when, specifically when, you just set the value for current HR. It's like turning a function inside out. But it kind of makes sense. There might be something that you want to trigger whenever current HR is set. Maybe you have a, what's a good example? Maybe if you had an app that, I don't know, has an object that you define that has 3 different colors, maybe every time your instance of that in your controller goes ahead and sets a new value for that object with those 3 different colors, maybe those are red, green, and blue values, maybe every time that's set, you want to tell the controller, hey, we just set the value here. You should go ahead and use that value to update the UI. So maybe instead of calling another function, you would say right at the point where you've updated the RGB value of your app that it should go ahead, update maybe the background view.color. Or, sorry, the view.background color. So maybe at a certain point when you're figuring out what your models, your controllers, and your views do, if some information or data is updated, you want your controller to handle what should happen when that information is updated. So a property observer sits there and waits to see, did we set the value of current HR here? When that happens, what's going on in this code? Hildy, can you walk me through line 19 to start? Tell me about those two words together. Okay. There's a specific phrase we have because current HR is an optional. So what we want to do in this line is we're checking to see that our optional has a value in it. Do you remember what that pattern is called? This if-let pattern. Do you want to phone a friend? Do you want to phone a friend? Optional binding. Great. So on line 19, we were using optional binding to check that current HR, so the variable that we just set, has a value. If it does, current HR is going to set that value, so an int, not an optional int, to this current HR constant that we're going to use in this block of code. If it is an optional that has no value in it, what's an optional that has no value? What's another way we can say that? Nil. Great. If current HR is nil, then it's going to go to the else condition. So if current HR has a value, print the most recent heart rate reading is, and whatever that value is. Otherwise, looks like we can't pick up a heart rate. This is how we might use nil for error checking. So as your apps get bigger and bigger and bigger, you're going to have to check that you got things working the way you want with the data that you were given. That's why optionals are so important. Because if there's no information there and you expected some information and you got a nil, then you can tell the user, this is not working in the right way, let's try a different way. Looks like we can't pick up a heart rate. So that is what our property observer does there. All right. This function, start heart rate monitoring example, says, so it's a loop that says, do this 10 times for the range between 1 and 10. So if we're not using the value of 1 and 10, at 1 through 10 in this, it's just saying, do this 10 times. So do this 10 times. Let random HR equal 60 plus int.random in a range 0 to 15. So 60 plus some random number between 0 and 15. Current HR is going to be that random number. What do we know about current HR when you set a value to it? What's going to happen?
You set a value to it. When you set a value to it, it set will pick up that value and it will print a message.
Great. So we have set a value. That means that this will trigger did set above. Let me put this in the right line. That should go there. We're assigning a value. So we've set a value to current HR. It's going to trigger all this. So it's going to say, do I have current HR? If I do, print some stuff. If I don't, looks like we can't pick up a heart rate. Great. Then this line just means stop doing anything on the current thread. Don't worry about what a thread is right now. Don't do anything for 2 seconds. on this thread. Great. So that is our heart rate receiver class. If you had to describe it, would you say this is a model, a view, or a controller?
Model.
I agree. So this is modeling some information and what that information should do. This is not connected to any view, so it's not a controller. It's modeling how some data should be used. Cool. Let's go to our heart rate view controller. It's a UI view controller that's got a label. Type. But this is not an outlet. This is something we're creating in the controller to eventually use in the UI. This is a different pattern of creating UI than Interface Builder. So whereas we've usually used IB, this is creating UI using a, I don't know, discipline or a pattern or something called programmatic UI. This is where we write all of the code for our views in our classes, and then we add them to our views. Programmatic UI doesn't even use a storyboard. Sounds hard. Let's use a storyboard. Let's keep, like you and me, let's all just have an agreement. We're going to use a storyboard. This seems tough. Great. So all this heart rate view controller has right now is a UI label. That UI label it's not on the UI yet. It is just like any other variable that we declare. It is a variable of a certain type. That type is a UI label, and it's been initialized as an empty UI label. So let's look at the initializers for a UI label. I could initialize it with something called a coder, which I don't know what that is. And I can initialize it with something called a frame, which I don't know what that is. I'm going to just initialize some empty one. I want a label, and I've got a label. If I initialized it with one of those two other things, I would have given it some properties, but right now I don't even know what I want to do to it, so leaving it how it is. Great, let's get into the questions. First, create an instance of heart rate receiver and call heart rate monitoring example. Alex, let's create an instance of heart rate receiver. Go. Nice. HR receiver. Heart rate receiver. Let's see, does it need any initializers? No. Great. Now what's the next thing? Create an instance and heart rate receiver dot start, all that stuff. Great. That's what it says to do. Let's run it in our playground. Don't we all feel so safe in our playground? Isn't it really nice? Cool. So if you remember, this function is going to run 10 times. It's going to get a number between 0 and 15, add that to 60. It's going to set heart rate to that. Heart rate's did set is going to go print some stuff. And then it's going to put it to sleep for 2 seconds. So it printed 10 times with a 2-second interval between each of those iterations. Can you say that a little louder? Sorry. Yeah, it might seem a little analog, but here's one way you could do it, is you could say print 1, put it to sleep for 1 second. I know. Print 2, and then put it to sleep for 1 second again. And then 2 seconds have gone by and you've printed 1 and 2. So that's like the simplest solution I can think of. I'm sure there might be a much more beautiful way to do it, but this solution would probably work in any coding language, right? Just print 1, wait a second. Print 2, wait a second. Kimball. I would not worry about that right now, but the description I'd give you is that thread is the, so thread's a type. So this is a type method, right? Or static method. And thread is the current line of code being operated. There can be multiple threads. You can be running code concurrently, so on different threads at the same time. But this is probably referring to the main thread, which is what your app generally would run on. If I look at my syllabus, I'm going to see that threading, I don't think comes until unit 4. So for now, just this means wait 2 seconds in the current lineup of things that are being processed. I think when you do queues in your DSA, you'll learn more about what a thread is. And if you're interested, you can look up what queues are. A thread is a real-life example of a queue. Okay, let's keep going. I've done this. I'm going to delete that. Get out of my way. In a real app, printing to the console does not show information. You need a way of passing information from the receiver to the controller. To do this, create a protocol called heart rate delegate receiver. Okay, let's create a protocol called heart rate delegate receiver. I'm going to pull all this crap up with me. I'm going to put that here for me so I understand it. I'm getting rid of all this stuff. I don't need it. I don't need any of this stuff. So I'm just going to do that here. I'm going to define my protocol up here, which is great. Protocol. What's my protocol called? What do they say to call it? Awesome. Heart rate receiver delegate. That requires a method, so a function called heart rate updated to BPM, where BPM is an int and represents the represents the new rate as beats per minute. Since playgrounds read top to bottom, and the two, wow, I already predicted this, and the 2 previous declared classes will need to use this protocol, you'll need to declare this protocol above the declaration of heart rate receiver. Nice. All right. So if you remember, a protocol only needs the signature of your function. We got it so far? Only needs the signature of your function. You will define the function within the class. There's also something I want to come to right at the end of this question, which is another place that you can define that function if you want your protocol's function to work in a specific way. But for right now, when you define a protocol, you just put what the function will look like. You do not actually give it its functionality. So you'll say, it's going to be called heart rate updated. It's going to take one argument that the user fills in as 2, and then as a parameter is used as BPM. Whatever that value is an int. Great. Let's make let's make the receiver conform to it. Heart rate receiver delegate. Our program is going to yell at us now. It's going to say it doesn't conform. It's going to do us a favor and say do that. Let's see what the instructions say to do in it. Now make your view controller adopt it. Great. Now make your view controller adopt it. Inside the body of the required method, you should set the text of heart rate. I did this in the wrong place, sorry. Let's undo that. Let's do it here. So this view controller inherits from UI view controller, and it also adopts the protocol heart rate receiver delegate. It's going to give us the stub again. It's going to say, give me that stub. Great. Inside the body of the required method, you should set the text of heart rate label. So this label we have down here, set the text. I don't know what it wants to set the text to. Let's just say set it to the BPM there. And print this user has been shown to have a heart rate of. What value should I put in here? BPM. Awesome. How you doing? Oh. I'll make it a string. How's that? What about you? No, I need to put that. Great. All right. I have done that. I'm going to delete the instructions. I want to keep going quickly so that we can get to coding later. So here's another way of using delegation. So protocol, I said, was an example of the delegate pattern. Another way that we can use the delegation is to literally insert the delegate as a property of a class or a struct. So I can create, let's do exactly what this says. Let's create something called a delegate, which is it's an optional heart rate receiver delegate. What? This is saying I want to directly use this heart rate receiver delegate. Instead of defining how it will work for my class, I want a delegate inside of my class that will use it. And now, if you're ready, there's the next part. In the did set of current HR, where current HR is successfully unwrapped, call heart rate updated, so this function, to the delegate property. What? So if this is successfully unwrapped, call, so delegate dot heart rate receive for current HR. That's what it wants me to do. Sunny.
Why do we make it an optional protocol, and why do we not need to unwrap it when we use it?
Over here, unwrap it. Let me.
When we make the variable delegate, why do we have to, in this case, make it an optional?
Yeah, let me answer this first. Because this is a delegate, this is optional chaining, which is saying like, if you find this thing here and it has a value, so if you find that delegate, do this thing. So it's, instead of unwrapping it, it's saying only in the case where you find something and it's not nil. Delegate, we're going to talk more about the delegate pattern on Monday, so I'm going to save that till then. But it's weird, right? It looks kind of weird. There's a specific time where you're going to use this and a specific time where you're going to use protocols. I know that didn't really tell you much yet. Cool. Let's keep going. Finally, return to the line of code. Oh my God, we're almost done. Return to the line of code just after you initialize an instance of heart rate receiver and initialize an instance of heart rate view controller. Niwa, can you help me create an instance of heart rate view controller? I'm just going to be lazy and steal that. Awesome. So we've got a new view controller. Check this out. Our heart rate receiver has a property called delegate that is an optional heart rate receiver delegate. Maybe this will help answer your question. What that delegate has to be, just like we saw yesterday with question 5, where we can create an array that has 3 things conforming to the same protocol even though they're different types, so long as our delegate conforms to this protocol, so long as whatever we assign to delegate conforms to this protocol, we can use that whole thing. So, initialize an instance, then set the delegate property of your heart rate receiver. So heart rate receiver dot delegate is equal to heart rate view controller. So the delegate is going to save as its value this instance of heart rate view controller, which conforms to the protocol heart rate receiver delegate. So I assign to delegate something conforming to heart rate receiver delegate. That specific thing is an instance of this view controller. And now I can use this delegate as if I have something that implements this protocol. So I can call the method we defined in our protocol, or the method in the function that's created in our protocol from my delegate. So from an object saved as a property, I can call this method by looking at my delegate and calling its specific implementation of heart rate updated. So now I can go ahead and say heart rate receiver dot delegate, and the delegate itself is a specific object conforming to heart rate receiver delegate, the protocol. Just like we saw yesterday, the delegate itself is actually a view controller. But the way that we are using it, because we've said whatever my delegate thing is, it's going to conform to this protocol, the way that we're going to use it, the way we're going to use our protocol, the way we're going to use our delegate as if it's something that just is defined by that delegate. So if you remember the cows, dogs, and cats example yesterday, this delegate only gives us the functionality of something conforming to that protocol. And so something conforming to that protocol only has the function heart rate updated and blah, 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 blah. So it only has this one function in the delegate because the delegate itself is a heart rate view controller, but we only have access to the protocol stuff there. I know this is like really fun. We only have access to the protocol stuff there because we've said that our delegate implements that protocol. So we're using our protocol in a completely different way, similarly to how we used our cats, dogs, and cows yesterday. And so if my heart rate receiver, which is of one type, uses its delegate, which is of another type, but conforms to a protocol that we are saying our delegate property needs to conform to, I can use that second type, so I can use this heart rate view controller as if its only functionality is what's defined in the signature, what we defined for this method from its signature. That's cool. It's going to be very helpful when we start to make more and more apps, use more and more delegates and things, blah, blah, blah. I want to just show you one last thing and we will take a break and then we'll start today's lesson. let's say I didn't want to do any of this. I didn't want to have a heart rate view controller. I instead wanted to just say every time, let's say heart rate receiver delegate has a whole bunch of stuff in it. It's got a func that's like do some other stuff, and it does that, and it's got some properties, a var something, which is an int, which is read only. If I want to define the actual behavior of these functions for my protocol, so let's say I want to do some other stuff to do the same thing every time you implement this protocol, you create an extension. So here's a new thing, an extension of heart rate receiver delegate. This extension only has access to this property and these two functions, and its job as an extension is to actually define what those things are. I don't know what to do. Print XYZ. So this extension is now saying anything that conforms to the protocol heart rate receiver delegate will have a function called do some other stuff that actually has an implementation. So if you want your protocol to have an implementation for one of its functions, let's see if we could also do it with the var. Var something equal to 10. Can we do that? I think so. Let's see. Nope. I lied. So use your extension if you want implementations of your protocol to actually function in the same way. So if you want anything implementing this protocol to actually use this function in a specific way, you extend the protocol that you've already given the template for, and you actually tell me how that thing is going to work. Sunny.
So you would use this if you had multiple classes that would have the same function. You don't want to repeat that same code multiple times.
Right. And you can think of this as, let's see. Now, in heart rate receiver, let's say that it conforms to this. And so it'll tell us the stubs in just a second. Give me the stubs, give me the stubs, give me the stubs, give me the stubs. Thank you. If you notice, my stubs don't need to include this function. So the extension has already defined this function, which is part of the template. So in order to conform, I don't need to define the behavior of this function that was in the protocol. I think that's cool. So you just call it in there. Yeah, so you can just use it. Like it's kind of working behind the scenes as if you've got a class that inherited from a superclass. It's some hidden information. But you can go back and see the extension. Cool, let's take a break. Hey. I'm going to put it on GitHub. Yeah. Jesus Christ. Get you out. Come on. Hey. Hello. What's going on? Mm-hmm. Okay. No worries. Okay, today we are going to talk about two kind of divergent things on your app, but they're cool. Life cycle and control. So, let's add this here, 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 here. Computer is angry. All right. So here, I've got a brand new app. Before we get into it, has anyone done any cool stuff in Xcode? Like, try running onto an iPad or what? Has anyone done anything cool in Xcode? Never? I don't believe you. All right. Well, there are a lot of cool features. Kevin, what'd you do? What? Uh-huh. Switched it to the bottom. Whoa. Whoa. The assistant view? The assistant editor? Let's check it out. How'd you do it, Kev? Sorry, Kevin. What's that? Uh-huh. Editor is on right, editor is on bottom. Woo. Cool. Editor is stacked horizontally? What does that mean? I don't know. Looks kind of like the same thing as on right. Vertically. All right. Thank you. Thanks so much. What's this? What is this? I don't know what this is. Has anyone seen this before? This is XML. So you remember I said storyboard is saving everything you do? This is what it's doing. It's saving it in all this stuff. Let's look a little more closely at it. Why don't we? Never mind. So XML is a markdown language. All a markdown language is, because you're going to see these in the future a lot. All a markdown language is a series of keys and values. That's it. And then, to use a markdown language, you must know how to look for the key that has the value you're looking for. So, Xcode, and when you compile an iOS app, they know exactly what to look for when they're looking at your storyboard. You don't have to worry about it. This is what's going on behind the scenes. That's cool. I thought it's a cool thing. Okay. One other thing that you might run into that I just want to show you what's going on is sometimes when you're looking at a class and you have the assistant editor open, you're going to see something called internal class. And up here it's going to say the interface. Has anyone seen this before and been confused by it? You X'd it out. Okay. So you just ran away from it. Okay. So let me tell you a little bit about what this does. All this does right now is it tells you how if you wanted to use view controller, so right now we're writing all the code for view controller and we're giving it all its information it needs. The interface is how other files will use your view controller. So if you have a class, this is going to say how something else might use your class. So your interface is saying, all right, there's a class called viewController, and it's got a function called viewDidLoad. So if I had another function called do something, then I'm gonna close my assistant editor, I'm gonna reopen it. It'll say in the interface, oh, if you want to go use that view controller thing, it's also got a function called do something. So if you're looking at the view controller from the outside, you're not seeing the definitions. You're just seeing the signatures of the functions. What you won't see is you won't see anything private to the view controller. So private function, do this only in here. I'm gonna close this and reopen it. Will not be in the interface because something else using my view controller cannot call a private function that's defined in my view controller. All right, it is 11:21. Everyone stand up. No, you're not. It's almost like the sugar we gave you was a bad idea for the morning. Put your hands up in the air, all the way up. Okay, and exhale. Your arms down. Run to the cookies if you want to. Okay, so that's what your internal class is. That's what that interface is. We're not taking a break. Sorry, hold on. That was just to get some blood flowing. We're going to continue the lesson. So, we're going to talk about two different important things today. The view controller lifecycle, which tells you how a view controller is appearing on your screen. Sorry, how a view controller makes views appear on your screen. It says, did I get them there? It says, will I get them there? It says, are they going to run away? Am I going to get rid of them? And did they run away? Your app keeps track of all of these states. A view controller inherits the ability, so our view controller we've got here inherits from the UI view controller the ability to know what point it's at. That's weird and abstract, right? Yeah, I agree. So another way we can put it is, we can say, think of your view controller as something that's alive. It has to be born, and then eventually you know what happens at the end. We call this the life cycle, right? For creatures, it's the life cycle. We talk about a view controller's life cycle from the beginning, when it is born, so when it exists, then its changes, so, you know, like cool stuff that happens being alive, and then when it dies. The view controller controls views. So throughout the life of a human, they do some stuff. The view controller has a much more boring life that we'll learn to make more exciting. Its job is to control views. So, what have we seen is automatically created with a view controller? Let's have a look-see over here. Whenever I've got a new view controller, what does it have in it? It has a view. What's that? And a safe area. We're not worrying about the safe area right now, but for each view controller, when it's created, it's got self.view, which is this view that covers the entire space of the view controller. That view is its main view. Let's call it that, or let's call it the content view. That gets loaded, it appears, and then it disappears in the life cycle of the view controller. Do you want to see how it works? Cool. What is something that we've seen and that we can currently see by looking at my screen that is part of the view controller life cycle? Great. View did load. By default, our view controller, when we create a new one, wants us to override view did load and say, when this view was loaded into our view controller. That's different from other things we're going to say, other things we're going to see. This is when we start to create the object that is a UI view that gets put into our view controller. It's not when the view appears on the screen, it's when we start to load up that object. Appearing on the screen is a different process. Ready? I'm going to show you a picture. It's a pretty neat picture, I think. I think it's cool. I didn't make it myself, but whatever. Okay. So, this is the life cycle of a view controller. Wow. Let's talk about what's going on. Let's say disappeared is a state of non-existence. So before birth and after birth are the same thing for a view controller. If you ain't there, you ain't there. There's no heaven for view controllers. Okay? Sorry. A view controller becomes a thought in our head. So we say view will appear before the process of appearing. So a view reaches a point of appearing before it actually appears. Think of these as parts of the life cycle. Before it actually shows up, it's in a state called appearing. Then it appears. Then it has another state called disappearing. And then it's finally gone. Those are the states of our view controller. That's the life cycle. These arrows are the verbs that we use to describe those states. Tell me about the arrows, someone. Those are verbs, those are functions that describe what is happening to the view controller in each state. Rob. Yes. Let's get to it after we figure out what one of them is. Okay? So just pick one of these verbs and tell me what you think it does. Let's start with view will appear. B. Yeah. So I'm going to stop with the human example here, and we're just going to say there are 4 different discrete states. There are specifically 4 states that a view can be in. When it goes from not existing to beginning to exist, so appearing, we can use the function view will appear. So it's not yet on the screen. Its state is not yet on the screen. But this is the point where it goes from just being nothing to starting to be configured to appear. So initially there might be some background color, there might be some other properties. You can think of this as instantiating your view. And then appeared is when it actually appears. Or initializing your view. And then this is when it actually appears. So when it goes from nothing to being initialized, that's view will appear. Similar to an initializer function. Yes?
So, if one way to think about it, the four stages of what's happening in the view, and then the arrows are what's happening in the controller, that's the function.
That's wonderful. Yes. So these are the states of the view, and the arrows, which are functions, are what's going on in the controller to make the view go where it's supposed to go. I think the important thing to think about is appearing and disappearing are changing the instance without changing the UI. So changing the view without adding it or removing it from the UI. It's in a state of disappearing or appearing when it is about to appear or disappear, which is really weird. But those need to be in specific places because if we just had disappeared and appeared, we wouldn't be able to configure anything about the view. So we say there's an intermediate stage between not showing and showing, and then showing and not showing. Disappeared is not showing, appeared is showing, and then there are intermediate stages. And then each of these functions is what the controller does to the view to get it into those states. In each of these functions, you can define some functionality. Think of view did load, right? That's part of the view controller lifecycle in a different way. Yeah, I'm okay with that explanation. That's part of the lifecycle in a completely different way, but you can put some functionality in it. You can say, call our superclasses view did load, which tells you how to get this thing working. And you can also do some other stuff in here. You can change some background colors, you can change up the view, you can do all this stuff. Let's see these things in action. But this, I would draw this diagram with your hand. Like, draw it by hand. Know that the circles are states for the view, and know that the arrows are functions in the view controller. Let's see these in action. Ready, set. In our view controller, we've already overridden view did load. I'm going to just work in the actual view controller Swift file. I'm going to comment that this is not available in interface, as we saw before, available in class interface. Class interface. Great. All right. So I had to create an override function for view did load. Let's say I want to create view will appear. How do you think I can do that? I'll just start declaring it because it inherits it from its superclass. So view did appear. It's going to tell us how that should work. I'm going to just leave it here for a sec. Yes. So because I inherit it from my superclass, I need to say this is an override function. Great. And now in my override, I'm going to call super.viewDidAppear for this animated. So I feed in that argument to my super view. Let's take a look real quick at this though. Let's just talk about override functions again. So if you hit Command B that compiles your code. So if you're not seeing any errors, but you don't want to run it yet, that builds your file and it tries to compile it into an app. It's not running it onto the simulator yet. That's a good way to check that you don't have errors in your code. So that's Command B. When I override my superclass's function, I do not need to call the superclass's function. I'm just overriding it and say, instead of my superclass's view did appear, do the stuff in here. But for lifecycle functions, it wouldn't make sense not to call the superclass's lifecycle function. So for view did appear, I'll want to call the superclass's version of that so that it can do everything it's supposed to do. Right? I want to call this so that my view controller works the way it's supposed to do. Built into your view controller are these lifecycle functions. That's nice. But I can also do some other stuff in here. Let's say I'm going to print view did appear. Great. That's great. I just want to see these things in action. So I'm going to do the same for view will appear. Let's see. Who can tell me what I might want to do first in this function? Malcolm. Can you tell me, so I'm creating another one of my lifecycle functions in my view controller. I already created view did appear. I did some stuff with it. Now I'm creating view will appear, which is a different one that occurs at a different point in the lifecycle. And I want to write that. What do you think I should do here if I'm overriding my superclass's view will appear? What can we do to make sure that our view controller still does what it's supposed to do with this function that's defined in the superclass? I'm going to give you a hint. Do something similar to what we did in view did appear. Cool. Awesome. And then here I'm going to fill in the parameter that I get from this call. So whenever you're using a lifecycle function, I would say by default, just make sure you're using super.that same function. Yes. That means will this function, so will this animate? So this is telling you what the view is doing, and it's saying, should this be animated? As opposed to not having some cool, like, UI-friendly portion of it. You can say what the animation should be. That's much later on. Tia. I like that. Yeah, so if you double click on something, the space, the period of time before you actually see it is will appear. And then it appears, and then when you exit out, that period of time right before it goes away is disappearing, and then disappeared is when you finally don't see it anymore. That's great. You could also think of it as like, you could think of appearing, which is kind of a weird thing to think about, as when you just, it's easier on a website, right? If I go to, I love showing this website because I think it's really bad. I used to work for them. here. So right now it's appearing, then it appeared. Right now it's appearing, then it appeared. They're tracking us. That's what this means. Anyway, right now it's appearing, then it appeared. That's great. So it is a period of time that you can keep track of, and it's super important because you have to say what should be done right now. What should be done before you actually see it. That's the appearing state. Yes, Sunny.
Early values that are coming into this function, are they determined in the model? Like, for example, you say if something happens, then you do here it's equal to true or false, and how
You could do that. You could change those animated in a variety of ways and when these are called. But these are actually called, these are called by themselves when a view controller is loaded onto your screen. So you yourself don't have to call them, but you can define how they should work. So when you boot up your app and it starts loading the view controller, in view will appear, you can say do some stuff here. So you could, that's probably where that would be the best place to set your background color. Because you're saying, okay, before you actually show the view, set the background here. So these are different points when the app exists. You don't have to call it. An iOS app knows how to use a view controller by its definition. Adam. Sorry, can you speak louder? Mm-hmm. Yeah, so the web and an iOS app actually work a little differently. Let's just talk about an iOS app. When you've compiled your code, it's compiled into a file. It's, I guess, like a package of files. You can do a variety of things with that package. You could actually send that package to someone else without even running it. That's how you get an app into the App Store, is you just compile the code, and then you send it to Apple and say, here's my code. Put it in the App Store so that other people can download it. When it's going into your simulator, it's taking that package, and then simulator is like, if you think about it, it's a very advanced program that has to go into that package of files, and it has to know how to run that. So that's why an iOS app won't work on an Android phone, because Android phones don't know how to run that specific kind of file. They must be, whatever you're using to run your iOS app has to be configured to run that specific kind of file that we create when you have an iOS app. I love that expression. Alex.
So, it's like when we use Instagram, right? Like when it's loading, it has like those placeholders.
Mm-hmm.
So is that on the, where in this does that appear then? Like, will it appear?
Yeah, so actually what they do is they load a view with those placeholders that themselves wait until the image appears, and then it replaces that placeholder in your view there. So it's kind of meta in the sense that your placeholder, which has the loading screen, is itself a view that's appeared. And then it's kind of waiting for another view that has a photo in it. So that's my person.
Okay. I forgot one.
I'm gonna stop trying. I don't know how to make that like default person image. So it's trying to load my photo, but it's in the appearing state until the photo is an actual kind of file, right? Like maybe it's PNG, maybe it's JPEG or something like that. It's waiting until it's actually received that whole photo file, so it's appearing. When appearing is all set and done, it moves that view into where your placeholder was. Sunny.
I think what I was confusing myself because I thought that these were for any like view objects, but this is just talking about the whole view itself.
Yes.
So if we were like what you had done previously in view did load,
Sorry.
we can now put in view did appear for like for what we had done in the past, like type of game or the color changing game, we can now put in view did appear because that's kind of view is currently there.
I would say if you want it to appear when you first see it, you'll want it to do that before view did appear. So if you want to set a background color, you probably want to set that before. If you want to set the property background color, you probably want to set that before view did appear, because by then the view's already there. So you want it to, before you're in the appeared state, which, should I redraw that diagram? Before it's in the appeared state, you want to set that property so that when it appears, it's already ready to go.
This is kind of like a cube, it's that.
It could be modeled in many ways, but I would think of it as like a person living and dying. It's really a good example. That's why it's called a life cycle. Okay, I want to do a couple. I want to just show you a couple more of these, and I'm just gonna go ahead and type them all out for you. Look at that diagram, which is in your curriculum. I just stole that from Apple. The diagram is in your curriculum. Look at when these happen. So, override, function, view, did, view will disappear. I'm going to call the super classes view will disappear and feed in animated. And then I'm going to print view will disappear. I'm going to put these in the order in which they appear in our life cycle. And we'll print them out and see when they all actually occur. And the last one, what's the last one called that you see there? View did disappear. It's going to call super.view did disappear. It's going to take animated in there. Great. Thank you. Let's see, do I want to run this yet? Yeah. Thank you. Sorry. I didn't sleep much last night. View did disappear. All right. I'm just going to run our app. We didn't add anything to the UI, but we have a view controller, and it's it's going to have a life cycle during which its content view will appear, then it will have appeared, and then if we do some other stuff, it'll disappear, or it'll be ready to disappear, so it will disappear, and then it will have disappeared. That's what we can say. So these functions are the view controller's life cycle. These functions act on the content view in the view controller. These are things happening to self.view in the view controller. Let's run. Oh, I don't have simulator open. Lego. Come on, come on. Come on. Patching. Nice. Running. Running. Cool. So right now, our view controller loaded. Maybe I should add a background. Our view controller loaded there. I'm going to add a background color that's gray. Run it again. So you see really quickly what happened? Before the gray showed up, the view will appear state. Printed out, view will appear. Then, when the view did appear state, then when the background color showed up, it printed view did appear. Let's watch that again. I know it's like, I can't do a slow-mo of it. Okay, one more time, just for fun. So before the view shows up, we're in appearing state. That's what view will appear is talking about. Then, when the view shows up, it's in the appeared state, and that's what the view did appear is talking about. Yes? I would think that's fine. However you need to think about this. There are many analogies for this, but I think the functions themselves describe where you're at. I think they are good descriptions of where you're at. What don't we see from my output there? So we don't see anything about disappear, right? So I'm going to get ahead of where we are in our syllabus to show you how that works. If you don't remember how these next parts work, that's fine. We're going to create another view controller that this view controller goes to. So I'm going to create a button on our view controller. How do I get my objects library open? I was going to ask someone. I was like a shark in bloody water already. Okay. Call this go to next BC. Great. Gonna make the background here that gold color. Nope, that's the font. Sorry. Gonna make the background purple. Great. You ready? Are you ready? Okay. So if I click my view controller, if I right click on it, sorry, if I go to editor, I press embed in a navigation controller. Whoa. And yes, you sneezed. Okay. Okay. So you do not need to know what this does yet. You can definitely use it, but there is much more that goes into this. This is how you navigate between like view controllers in your app. This is why like if you tap one thing, it presents one screen, and then you can go into another screen from that other screen. Those are different view controllers. We're not going to talk about multiple view controller apps for another week. But by clicking on my view controller in the storyboard, I click editor, I scroll down to embed in, and then I click navigation controller, and it creates this navigation controller. We'll go to step 2 in a second. Albert. Say that again? I'm not sure I
That's
understand.
if we're gonna have two control transfer files.
Yes.
Right, more people.
Yes. So we're going to have, we've seen, if we create multiple models, it's just like a rock.swift and like a paper scissors.swift. We can have multiple view controller files as well that'll each have their own view controller setup. We're going to add another view controller right now. So we'll see that. Ready? Okay. We've got a new button. We've got a navigation controller. This is going to enable us to start at our view controller. And then what I want to do is when this button is pressed, it will lead me to a new place. I'm going to go into my objects library. I'm going to type in view controller. I can drag in another view controller. Neato. Let's see what happens when I do this. If I click this view controller and I try to open its assistant editor, it thinks that this view controller is just another instance of my view controller. So if I tap the view controller on the left, and if I tap the view controller on the right, it thinks that it should load open my view controller. But if I go to automatic, check this out. If you remember, with our view controller that's defined here, if I go to automatic, it automatically leads me to the viewcontroller.swift file that it created when I created the app itself, the project. This view controller, when I go to automatic, just goes to, this is the definition of a UI view controller. So the class that our view controller inherits from, that's what, by default, the Xcode project thinks should be the class of this view controller. So this guy right here in the assistant editor, if you click this button, you just click on automatic and let it do its thing. There is no custom class for the view controller I just created. And that's where, when we go to the identity inspector, we'll see it's just the UI view. If I go to the view controller and go to the identity inspector, it says it's just the UI view controller. Whereas if I look at my first view controller that I created when I created the app, if I go to its view controller, it says the class is view controller. And that's the custom class we've been working in. That's different. I can create a new view controller file like Albert was asking. I'm going to do that just to show you what happens. This is going to be called second view controller.swift. I'm just going to steal some code. So right now is a good time to use the manual navigation over here. I'm just going to steal some code, all that. Blammo. I'm going to just print in the view did load. Print second view controller loaded. I'm going to get rid of the rest of these. It's protesting right now because I'm trying to declare this class the same place as before, so I need to change the name of the class. It's the second view controller. Second view controller, great. So now I have two view controller files like Albert wanted us to do. I can now go to this second view controller and make it a second view controller. So now this view controller knows that the way it works is however that second view controller class says it works. There are two different classes for two different view controllers here. We do not need to know that much about them right now. We just want to see how they load. So what can I do, Olympia? How can I make this button lead me to this second view controller? I've got my initial view controller, and it's embedded within the navigation controller. Now I want to press this button and show this second view controller. I segue. What's a segue? Neato. How do I create a segue? Whoa. Action segue. So it can show a whole bunch of different ways, and those are all built in to Interface Builder. Neat. Now I'll see this funky looking thing. That's the symbol for a segue. So there's a connection between these view controllers that is a segue. If I click on it, it can even tell me stuff about that because everything in UIKit is an object. The segue is an object. No. Do what again? Make a segue. Okay. I'm going to Control Z. So I start by saying what should be pressed. So think of this like an action. So if I hold Control and I drag, just like with an outlet or an action, then I drag it to that second view controller, it's going to say, oh, I see this is between an action and a target. The target is the second view controller. I'll create a segue. Great. Now, by pressing this button, I navigate to this second view controller. There's also this other thingy here that tells us we are in the navigation controller. Great. If we look over here, it says relation, root view controller to view controller. Great. It's just saying how they are linked. That's what these arrows with symbols mean. Again, we do not care about this right now, but I do want to show you what happens. Ah, I just cracked my knee and that didn't work. Oh, I didn't put a paren. Thank you. Thank you, error. That was so helpful. Ah, fuck. I'm okay. Ah. Okay, let's watch what's happening in my output. View will appear. View did appear. We trust that that's going to happen, right? Before anything happens, let's remember that I only put these print statements in my first view controller. I didn't put them in the second view controller, except for in the view did load. So now I'm going to press my button, which is going to first set, it's going to say we're going to my new view controller. It's going to that view controller is going to start by appearing its view, then the view will appear. Before that stuff happens, my first view controller will disappear, and then it will have disappeared. So it did disappear. Ready? Boom. Whoa. And check out what happened, though. It started loading my second view controller before it began to disappear my first view controller. So it made sure that button did something. It made sure it was able to, in the background, set up my second view controller before it went ahead and tried to do that. If it wouldn't have worked, we would have gotten an error. Isn't that neat? Gary's like, I will agree, just to agree. It might have not worked, it might have crashed. It depends how we set up the segue and the navigation there.
You can set stuff up so that before you go to one screen, like it loads all the information so that it's quick.
Where would you do that? Probably in the view did load, right? Because before it even gets to appearing or appeared, it runs view did load. Sunny. It is saying it's creating the object view. Putting it into the UI comes next. I love this. I'm doing a happy dance. Liana. Great question. We will do that part after lunch. Let's take a break now. The second part of this lesson is going to be quick, me showing you stuff that you can use with very minimal setup. And then you can all start coding. And that will give me enough time to finish my pairing algorithm so that I can actually put you in pairs. Everyone said they like it. You should pair this afternoon on your lab. What I want to do, which I might have to enlist someone else to do, hang on, let me just tell you the plan. Remember yesterday I worked through a project and I did all my Git stuff? I want to start working in like good practices into our lab time. So when you're set up with your pairs this afternoon, you will be pairing with someone and we will be managing our time as a class using something called the Pomodoro technique. So what that will be is you'll work for 25 minutes. You will take 5 minutes to not do anything code related. You can talk, you can go use the restroom, you can just stare off into space. After that break, you will switch roles. So we're going to do very strict pairing. Everyone in here with your pair using this time management technique. Cool? Neato. Let's take a 7-minute break. Is there no lab? What? Oh, sorry. I got so excited. Hold on. Ben. Hello, dear. Is there no lab?
Hi, David.
Hey.
Me and Sunny both have a wonderful question for you.
Oh, I'm not receptive to. Yeah. Sorry, I'm not receptive. Me too. Eric, where's Eric? Eric, thank you.
I'll leave you the honors.
Both
Yes,
of
sorry,
our
go ahead.
print statements for the second controller is not loading.
That's
Or
crazy.
printing.
What? Oh my god. Why?
Yes, David, why?
I don't know, you tell me.
Our button.
Let's go look at that function. The second view control. Interesting. Okay, let's go look at your storyboard. Interesting. Tell me about that segue. If you click on it, it'll show you a whole bunch of stuff about it. So, that stuff. Say the kind, which is helpful. That's an enum. What? Oh my god. Alright, so let's run it and see what happens.
Show, like you push the button, and if you push it, it will show, right? Is that what you mean by enum, like that
No,
case?
so it's something about how you're navigating to it. Don't worry about
Okay.
it. Push. Okay? So interesting. Click on your second view controller. Go to the identity inspector. That's the square one. Next to that. Okay. Now click on view controller here. Interesting. What's the class there?
Oh, yeah. So it's still,
So it's just doing all the default UI view controllers, but you defined another class for a second view controller. So you have to tell this view controller its class is second view controller. Neato. Don't you love it?
so the original class was UI view controller, even though it was named something else.
So when we created a new view controller in our storyboard, by default, it just made a UI view controller. Yes. When we create a new project that's a single view application, by default that sets up one view controller that is linked to a view controller that creates its storyboard. So that's like the default starting point they give you. When you start adding multiple view controllers, then you need to do some other stuff. Interesting.
So our current view,
We really not
so the view controller that's made when we first start a project, the class isn't the class that we need for that Swift file, because right now it's UI view.
Well, look at what you have selected in the document outline.
Oh, here we go. Ah.
So you could, if you click view, you see that by default is UI view. You could have made a custom class there. For this button, you could have made a custom class. So they're all objects. What? You guys want to see a picture of my angelic niece?
Absolutely. How old is she now?
She's 1 month old.
With a blanket. Oh my gosh.
Very cute.
Born a model.
Not as great as some other
In
kids,
North
yeah.
Carolina?
North Carolina.
Precious.
It's great. Sometimes babies are ugly though.
That is something that we think and usually don't say
I
out
mean,
loud.
it's my my brood or whatever you want to call it. She's of mine. I bet you were,
I was a
Alex.
fat baby.
Yeah. What?
Second view controller load first.
Gotta make sure you have it, man.
Yeah.
It's amazing how much we forget. Like
I
I
know.
just reviewed this last night. It's like,
Yeah.
oh, cool.
Yeah. I love sitting in and refreshing all this stuff.
I'm sorry. That was yesterday. Oh man, everyone's got it now. Did you all know that song before I was going with it? It's a really good one. Should we just listen to music and not have a lecture? What's that? You are not going to pair program because there's not a lab. Oh, come on. Instead, you're going to get started on your tic-tac-toe. We're still going to do Pomodoro though.
have like a white one, a gray one, and a yellow one, right?
Yes.
And I know the gray one that
The first thing just says, the first thing, don't really understand that, but it sets up view controller so that they can navigate to other view controllers. A navigation controller doesn't actually like have a view, doesn't do any other stuff. Think of it like a controller that controls.
Okay, so if you don't have that, you cannot have.
That's segue. You can do it in different ways, but this is like by far the easiest. So you wouldn't like put a button in navigation. Okay. Are you ready for the rapid fire? Ready for rapid fire? Let's do some rapid fire. Okay, let's look at a button. A button is a thing. It's a UI button. It is an instance of a class called UI button. UI button inherits from control, UI control, which inherits from UI view. A UI control is pretty much anything that responds to user interaction. So you can create an IB action out of any control. Buttons are not the only controls. I'm going to show you some more right now. Boom. First control is a switch. Has anyone ever used a switch before? Yeah, it's exactly like a light switch. So it just has two options, on and off. On and off. Let's look at our switch. The most important aspect of a switch is whether it is on or off. That's called switch.state. Thank you, Olympia. This is turning it on and off. Look in my UI as I pick a different state. On, off. On, off. Okay. What do you think the type of a switch is? Yeah. No. A switch is a UI switch. Its property state is a bool. I know. I tricked myself. Okay, so if I were to create an action from my switch, I'm going to get rid of this guy. I'm going to lose some stuff. Oh, why is this so hard to? There we go. Okay, I'm going to create an action from my switch. Ready? Wablam. Wow, it works just like a button? No way. I'm going to make it an action. It's going to be, make sure you make its type a UI switch so that when you refer to it, you have the properties of a UI switch. I'm going to call this the switch. Nice. Good job, David. Thanks, bud. Okay, so now when I go and I talk about sender, sender is of type UI switch. I can call UI switch.state. I can find that out. That's a get method, right? So I can print that out. Great. So I'm going to print the current state of state. I'm going to print the current status of the button, whether it's on or off. Then I can also go and say, whenever I press it, sender.state equal to UI control dot state dot look at all these things. Which one is it? Olympia, which one is it?
What?
How do I make it on or off? Is on. What? Oh. Dot is on. UI control. Dot state is enabled. Dot state dot enabled is enabled. What? Help me out. UI control dot UI switch. Okay. A Boolean value. No. Is on is a bool. It's saying is it on or off. I want to set it though. Dot. Well, let's check it out. I don't know. It's not working though. Let's see what our error was. Oh. State needs to be control.state. Well, I don't know how to use it. So what should I do? So it is not a UI button because it's of a different type. How to change the state of a UI switch. What? How to change the state of a UI switch? iPhone setting UI switch. That's in Objective-C. We are going to run away from that. UI switch set state. Huh. Let's see. Let's check the documentation. Okay. Initializing the switch. Setting the state on or off. Is on is a get property. Set on is a function that allows you to set it on or off. The argument for which you should set it is this bool. Animated is another thing that's like, should we animate this? We don't know about animations yet, so who cares? Set on. Great. I'm going to say every time I press it, it becomes true. So now it's off. Let's make it work really stupidly. Ready? Damn, that didn't work. Sender.state. Cannot assign value. Great. What am I trying to do here that's wrong? Let's look at set on. Set on. What does it return? What does it return? It returns nothing. So I can't set state equal to whatever happens in here. Instead, I can just call set on. Now, I'm using a, check this out. This is a mutating function. What? Cool. Now, when I run it, we're going to see some printing stuff still. That's cool. Let's go. Show me more stuff. Whoa, view will appear and it appeared. Great. Ready? I press it. I press it and it keeps staying on. You see, as I press it, it like is doing some default animation. Cool. So that's what? This is all true. But what would make this easier? It would be nice if I could set up a function called let is this thing on, which is, check this out, a ternary sender.isOn. If it's true, then it'll say this will return true. If it's false, then this will return false. So I don't even have to, here could be a ternary, right? If it's on, so if this thing is true, I'll make this false and this true. That's kind of annoying. This is an anti-pattern again because you have a Boolean already. You should not be returning or assigning a Boolean. Instead, I could just say not this on. So that is just conditional logic. But what it's saying is the current state of this thing, before I go and I set its new state, give me the state, so tell me if it's on or off, and then assign to this constant, is this thing on, the opposite. A better name for is this thing on would be, let's flip the bool. And then let's flip the bool is what we would use to set our new thingy. You know, a thingy. Now, when I click it, it goes between the two states. Nice. And it's animating so nicely for us. If I turn animated to false, let's see what happens. The nice thing about functions that take booleans is you can test them really easy because you just have to test true or false if you want to know what they're going to do. Now when I press it, it's not animated in the same way. It's doing, I guess, some default behavior. It's not as cool as the other animation, so I'm going to keep it true. I'm going to keep going. Let's talk about another UI control. Yay! Everyone loves it! Yes! Okay, this one is called a UI stepper. How do you think I can get a UI stepper? Whoa. How do you think I can get a stepper? It's probably, if I'm going to use it in the UI, it's probably an object that I can get from the object library. Nice. So I can drag this guy out. I can put it right here. Wow, it's got like a plus and a minus thing. That's great. Let's see how this works. I'm going to make the background purple. I'm going to make the tint. So the tint is the colors of the, what do you call those? Borders and of the button borders. Tint is a property on that guy. That's cool, right? All right. Let's look at our stepper. It has a bunch of things here. It's got a value. It's got a minimum and a maximum. These are saying how high and how low the stepper can get. So if I keep pressing it, how high and how low can it get? I don't know. Doesn't matter to me right now. Let's make an action with this. So just like with any other control, I can make an action with my UI stepper. And I will say stepper, I'm going to call this stepper value changed. So this has a special type of event. The UI stepper is a special kind of event where you can say, what they did was they pressed plus or minus. That's what this value changed means. Now, when I go and I look at my stepper, when I look at the action of pressing plus or minus, if I look at sender, which is a stepper, I can say sender.value. So value is the current value of our stepper. Interesting. Sender is the current value of our stepper. I can also look at some of its other stuff. I can see what its maximum value is. I can see what its minimum value is. But sender itself stores some information about itself. What I might want to do is, because my controller, say I wanted to update some data using my stepper, I wouldn't link the sender.value here to a model because my view, which is the stepper, should not be connecting to my model. Instead, what I can do is have a variable called current stepper value, and that's going to be equal to 0.0 because sender.value is a double. Now I'm going to say every time my current stepper value is pressed, every time my stepper is pressed, set the value of this thing to that. So let's print out what happens here to see what's actually going on. So print sender.value, or a better way to do that would be to refer to the info in my controller. So I don't want to be I want my controller to interact with itself, not with the view constantly. So print here, then I increased it to current stepper value after I've set this value. So let's look at our print statements here. Let's see what I'm doing here. I'm gonna get rid of that. I'm gonna look at that. All right, let's run it. Okay, some life cycle printouts are coming. Awesome. Now I'm going to press my stepper. It says each time it's 9.0. Then I increased it to 10. Then I increased it to 11, 12, 13. Then I'm decreasing it now, or decrementing and incrementing. I can go to the stepper. I can say that its minimum is more than 0. I can say that its step, my computer is lagging like hell, is 6. Now what do we think will happen? The first time I press the button, what am I going to see? So it started at 0.0. Interesting. Very weird. What did I not set up on my current stepper value? So it started by default at 0, but the stepper itself started at 20. So maybe in my view did load, I should also say, right when this view loads, self.current stepper value is equal to, well, I don't know yet. Maybe I need an outlet. Maybe I need a way to refer to this to say, give me that thing's current value. So let's make an outlet. See how apps like involve a lot of stuff? Wild. I know. Okay, let's make an outlet. Nice. We got an outlet from my stepper, and it's my stepper. That's nice. All right. So I've got now a way to refer to that stepper whose current value is 20. So I want to update my variable. Current stepper value is equal to my stepper dot value. Great. So now when this loads, whatever default value I said this UI stepper item has will set to the value on my view controller. So we don't even need to initialize that. Psych. So wait, actually let me stop that. Stop. Can someone tell me why this didn't work? This is a class. There's no initializer for my class. So it's saying I went to make this class, but you didn't tell me how to give values to every property that doesn't have a value. The view controller is a class just like any other class we made last week and this week. It's just a class. So I'm just going to be lazy, not create an initializer, instead give it a default value. Let's run it. Is there a midday check-in today?
Yes.
Okay. Let's move that to the afternoon. Hey, Olympia, can you move the midday check-in to 1 o'clock or 2 o'clock? Thank you, Olympia. Okay, let's press the stepper now. Cool, it was 20, and then I increased it. It's going up by 6 each time. If I keep pressing it, it's not going to do anything once I reach my maximum. It's going to disable the button, right? If this is very hard to see, you should try making it yourself. Once I reach my maximum, the color of my stepper changes. So it does the default behavior of saying this is not enabled anymore. Made that darker. Now when I decrease it all the way to its lower minimum, it disables the decrement button. Wild. What's that? I think it's cool. Yeah, it has this built-in behavior. So it's its own type, its own class. Everything in our UI is a class. And it's got all this built-in stuff. It does all the work for you. That's tight. Let me show you one more thing about this little thingy here that might involve a bunch of things we've seen before. I know that wasn't really a helpful way of explaining what I was going to do, but let's add a label. And let's put, there will be some values here. Great. I'm going to bring this over here. I'm going to create an outlet. Nope, I'm going to do it below that property so that these things are all organized. I'm going to call this outlet the value of my stepper. What do you think I mean to do with this label? What's its purpose going to be? Allison, what am I going to display on this label? So I've got a label here, and I've called it the value of my stepper. What do you think I'm going to put there, if you were to guess? Yeah, and what's that int going to be based on? Where's it going to get that value from? Nice. And how do we tie the stepper? How do we tie the values of the stepper to this view controller? So we had a button, great, and then in the button we said something is going to happen when the stepper is pressed. That's what the button is indicating. Now, what actually happens in this function when the stepper is pressed? Okay, and based on that value, what are we updating in the view controller itself? So not quite yet. We're updating this variable called current stepper value. So something that's stored in the view controller, we're getting the views interaction, we're storing it in the view controller. And are you all ready for this? You ready for this? Every time the current stepper value is set, I'm going to say the value of my stepper dot text, so the text in my label, is equal to the current value is, I'm going to interpolate this exact thing. No, come on. Actually, I don't think it's going to let me interpolate it, but let's find out. Let's build it, see if I get an error. It's green. Green means go. Okay, let's run it. It's still running. I'm going to have like a 3-hour video that's going to take like 64 hours to process. It's going to be awesome. The current value is 20. Great. So when it was first set in the did set, so when our did set was called, it went and it got the stepper value. It assigned that value to this value in our view controller. The nice thing is, once it set that value, it went and it updated that label. Now when I press this button, it's going to trigger this action, which is going to set the view controller's value. So by pressing the button, I am not going to set the value of that label based on the value from the view. So a view does not update itself. That's crazy. The view doesn't update other views either. Let's look at it again. When I press, I don't know how to draw this. I don't know what I'm thinking about a marker. The UI stepper is one view. A label is another view. Views don't interact with views. Views only talk to controllers. So when I press plus or minus, I update a value in my controller. Then my controller knows when that value is set. So when it's updated, I'm going to go and update the label. Views don't talk to views or the model, they only talk to the controller. A model, in the same way, does not talk to another model. It might contain other models in it, but it won't itself go ahead and say, hey, I'm a struct of rocks and you are a garbage truck. I'm going to put myself in you. Instead, what's that face? I'm not going to put myself in there. Instead, there is someone who comes and picks up the rocks and puts them in the garbage truck. That's what the controller is. That's what the controller does. Blam. Now it's disabled. Blam. This is really cool. I'm sorry. If it's not cool to you, I respect your incorrect opinion. Should we do this right now? Okay, there are two more. I'm going to show you the easier one. It is called a slider. So a slider is a tiny kind of burger that you can represent in your UI. Just kidding. A slider is going to show up on the screen. Let's check out the slider's attributes. It also has a maximum and a minimum. Its current value is 0.5. What does 0.5 look like in the UI? Right down the center, in the middle, because 0.5 is right in the middle of 0 and 1. If I update the value in my attributes inspector, it's not going to go and work well. So if you see, I am updating the values, and it doesn't keep the maximum and minimum if I keep increasing it. That's kind of annoying. Also, this is really not working super well. Slow down, slow down, slow down. Okay, so I'm going to say right now, the max is 0 and the min is 1. There's probably like a good default way to use a slider, somewhere between 0 and 1. So between 0% and 100%. If it's a double, then you can talk about percentages, right? Slider is a great way to talk about percentages. Great. We're talking about numbers between 0 and 1. What does that almost sound like? It sounds like a range. The slider keeps track of values in a particular range. That's your minimum and your maximum. We've learned so many things. It's incredible. All right. So, kind of like with the other controls, I kind of don't even want to do this. You can figure out how a slider works. Cool. Anyway, think of it just like a stepper that has a current value, that has a minimum and a maximum, right? You can probably access its values by going to sender.value because it's named the exact same thing as the stepper. So the stepper has a current value, slider has a current value. So if I were to have an action from my slider, hypothetically, because I don't feel like doing it, if I had an action from that, I could check the sender's value. So I can look at the UI slider, that is the sender. I guess I'll just make it. And we'll make an action. We'll call this went slippin', slidin'. We'll make sure that it is a UI slider. We'll hit connect. Great. I can look at sender.value in here. Great. I could probably, I don't know, do the exact same thing that I did with the stepper. Come on. But let's just check in on something. Sender.value. Come on. Is a float. A float is not a double, but it is a decimal. It's a specific type of decimal value. A double just has double the memory of a float, if I got that right. I don't know. In most other languages, when you see a decimal, they'll refer to it as a float or a floating point. So good terminology to know. We use decimals in Swift. I'm just going to real quick set this up. So I'm going to make a variable called var current slider value. If I set it equal to 0.0, what does my program infer the type of this current slider is? Sam. It infers it's a double, and so I have to annotate that it is a float. I must tell it that. Now I'm going to say, let's say I add a label. I could do the same thing to update that label using didSet if that label was maybe the value of my slider, just by pulling and dragging that slider. So if I said self or just current slider, slider value is equal to sender.value. If I had a didSet, so if I had a property observer, there's so much terminology, it's so good, that waited until this float changed, then I could update the text of this new label. So let's say I want to be lazy right now, and each time either the stepper or the slider are updated, I just go ahead and I update that same label. This would be really bad UI because the label is going to reflect two different things. Let's do it. Nice. I broke it. Let's see. Super cannot be referred to outside. Oh, this is getting wild. Chances are I messed up some paren somewhere. If you see this everywhere, the chances are that you just didn't put the right number of parens. Boom. It's not that you broke the whole program. It's that it doesn't know how to read the file. Come on. Yeah, okay. Let's do it. Ready? Ooh. Okay, I hit my stepper, goes to 26. I slide my slider, goes to that. I hit my stepper, I hit my slider. See how bad this is? See how the UI doesn't even separate responsibilities? Am I right? Right? Okay. So, that's me being really, really lazy. You would probably display that information in two different ways. Okay, I think we can all get behind that. Now, okay. Let's just see what this one last thing looks like. I don't think, well, wait, there's no lab. So I don't think you'll be seeing this in any context today, but we'll be seeing it in future contexts. So let's just talk about first what we have. What's this thing called? A UI switch. What is a UI switch? What's the main purpose of a UI switch? Cool. True or false? So turning something on or off. Switching between two states. So I might have a UI switch where if I turn it on, the background color is red. If I turn it off, the background color is blue. And then it'll keep switching between only those two states. Kind of like an enum. Oh. What is this thing called? Cool. What is the actual type of this thing? It's not a stepper. It's a UI stepper. If you went to define it just with stepper, it wouldn't know what the hell you're talking about. It is a UI stepper. Think of everything in UIKit as good. Everything in UIKit is going to be prefixed by that UI. That helps you to organize your code, right? What if you created some model called stepper? Well, that would be different than UI stepper. That's helpful, that everything in your UI is prefixed by the letters UI. Great, what does a stepper do? So it increases or decreases its values. It has an upper limit and a lower limit. You can set a default value. Show me my guy. Yeah. All right, you can set a default value, so a starting value. You can say how low it can go, how high it can go. You can also say how much to go up by every time you press it. Nice. Before I show you in the code, what could I type? Say I have an IB action connected to this stepper for any time that you change the value. How would I access that value? And say that the variable name for my stepper is sender. How would I get that value, Jason? Yeah, so I've got a stepper, and let's say I've already attached an IB action to it. Nice. So that IB action has a parameter called sender. And that sender actually refers to the stepper itself. How do I get the value, the current value of the stepper in that IB action? Awesome, sender.value. This is just a nice layout for all the properties. The attributes inspector is just a nice layout, so like visually, for all the attributes that you can find in the code itself. I can find value, I can find maximum, I can find minimum, I can find step. I can adjust those all from my code. Neato. Yes.
You expect yourself having a little bit of rolling all or
The latter. So the biggest skill you can build, especially with UI, is to figure out what you want it to do. And then, once you figure that out, you'll start to see what the tools are that let you do it. So, perfect question. Yeah, but no, so we've got some tools here. A button lets you trigger any old action. It's a UI control. We're looking at some other UI controls, so things that will respond to user interaction. A switch you would probably use for a specific situation where you want to only have two things that can be done, an on or an off switch. A stepper might be like adding and subtracting something. So it's already a built-in element that lets you do this nice specific thing. A slider could be for some range of information. So when I hold this up and down for the brightness of my phone, that's a range of information. I don't know, honestly, if it's implemented like a stepper or if it's some custom thing they made up, but maybe this should be your lab for the afternoon. It's actually really simple. All you have to do is Google how you change the brightness of your screen. All you have to do is do that, and then your controller can control that. You can have a model that models that information. You get it. Sorry, I'm just talking a lot. But the whole point of a slider is it's a range, right? So these are specific tools that you all now have to do a whole bunch of shit. A whole bunch of stuff. You're welcome. What are some questions? Phoenix. Sorry, can you say that louder? Let's look at our syllabus. Or let me start with the question, would you like to have a lab about it eventually?
Yes.
So I think more so than any other lesson we've had before, this was specifically a tools-based lesson, right? I showed you a bunch of things you can do rather than a bunch of concepts that you need. you will use all of these tools going forward. Like, these are going to be very specific skills you can build on. So even if we don't have a lab, I'm stalling right now. Even if we don't have a lab for it going forward, you're going to use this all the time because I'm going to make sure that your lab, let me do this. I'm going to make sure that your next week's project, so the thing you start on next Friday, involves all these things. All of them. Except for this multiple view controller stuff, because we haven't learned that yet. But I did not answer your question. I only deflected it. And so let's go to your syllabus. Let's see what's coming up. It's August. It's wild. So you know you all came here like 2 calendar months ago? You came here in June. I know it was the end of June, but like, it's been a long time. Midday check-in, delegation through a text view, auto layout. Oh, this is awesome. UI table view, tight, UI table view, yes, custom UI table view cells. You're gonna use these tools all through next week. B.
Why is there nothing there for the 16th There's nothing there.
I'll tell you, like, we're only at most a week ahead, but let me see what I theoretically said was going to happen when I first created, or when I first laid out the curriculum. What's that? Unit 3 starts on the 26th. This is, going forward, I think I said this on Monday, going forward our units, because we know so much stuff already, are only going to be 3.5 to 4 weeks long. Which means that before you know it, you will no longer be at pursuit. Because not every unit is 5 weeks long. Okay, let's see. What do I got for next Friday? UI table view. Great. Then what's going on with the 16th? August 16th. So there's definitely going to be a project. We pulled it out of there because we don't like the one that we made. Yeah, so here's the one that they made, which we could do a vote if I should adapt this. Just know this isn't a democracy, but I am receptive to feedback. So make an app that shows you stuff about Game of Thrones. It should do a bunch of stuff. Navigate through it. I don't know. I still gotta figure out how to make this. And if I want you to make this. Let me start with if I want you to make this. Okay. So, B, in the very least, you will start a project that Friday. There might not be a lesson. I did.